Yes, good morning, friends. Welcome to the session once again. We are meeting after a week or two. Okay, so this month, another 15 session I will conduct. Okay, another 15 session I will conduct this month. Good morning once again to all of you. In the last month, I have conducted 15 session. Okay, 15 session of 40 minutes each. So in the last month, we have covered the comprehensive discussion of geomorphology. Okay, geomorphology. So this month, again, I am planning to conduct another 15 session, and under this 15 session, we will try to cover climatology and oceanography. Okay, climatology as well as oceanography I will try to cover. Clear? Now today is the first session, so we will try to cover the basic concept about climatology as far as your UPSC exam is concerned. But before going into the session, as we wait for some more learners to join in, I hope my audio and video is working fine. I'll be very happy if any one of you can give me a feedback in the live chat box below. Okay. Good morning and welcome to the session once again to all of you. Before we go into the session, let me just give you an information. In Unacademy platform, a new batches, see your prelims is there on 6th in the month of June. Okay, so only hardly 6 months now. Taking that into consideration, we have started in the Unacademy platform on December 1st a comprehensive course for your 2022 preparation. Okay, so you can still chip in at any time, and as per your timeline, if you are planning to sit for 2023, oh, Navin Kot, good morning once again. How are you? How is your preparations going on? For 2023 also, you can see this is the timeline. 5th June 2022 is the prelims. So accordingly, you can plan your schedule. Okay, so it has started from 1st of December. The mains 2022 will be 16th September. Okay, accordingly, for 2 years plan, that is, if you are planning to sit for 2023 exam, you can follow this particular timeline. Okay, also, as you know, for prelims, one of the best way to practice is through practicing of this MCQ. So keeping that in mind, Unacademy has this free test series. It is completely free. One happens every Sunday at 11 a.m. Okay, that is Unacademy Compact. Other two new introduction is T20 Daily Current Affairs. So any current affairs that we have, it will be on daily basis from Monday to Friday at 7:30 p.m. And also you have the static portion. Like for example, in polity, in geography, in economy, there are certain concepts which are static. Okay, some principles, some basic concept, some foundational value, some foundational informations that will be under Abhiyan series. This is also Monday to Friday at 10 a.m. every day. You can use my code, that is SUNEP10 as an enrollment code. Okay, one very important information is, you see here, there are 20 specific GS related books that is curated and designed by top educator in the Unacademy platform. Now, one of the important point is keeping the syllabus in hand and also the previous year's UPSC question. This book has been designed, which means each and every point which is there in the syllabus is covered here. Along with it, it is aligned with the latest trend, because UPSC exam as such is a very dynamic exam, and it is reviewed by the top Unacademy educator and also previous year UPSC toppers. Okay, it is available both in English as well as in Hindi. For enrollment, you can catch hold of this book. If you catch hold of this 20 GS book from Unacademy platform, you don't have to go and search, waste time and read other books. Okay, all the topics will be completely covered under this. You can use my code SUNEP10. Okay, chalo, let us go ahead with our discussion. Clear? See, before we go into the discussion, let me tell you one thing. You see here, if any one of you, okay, missing out on certain points that we are discussing, you can interrupt me at any time. I am here to clear your doubt. Okay. First point. The second is our main objective is to clear the exam. So I wouldn't mind clearing your doubt again and again n number of times. So you can interrupt me anytime and ask me the question. Okay. You can signal that in the chat box below. Okay. Chalo. Let us begin our discussion with under this climatology with the basic concept about what is this atmosphere. Okay. See, for an artist, it requires a canvas in order to draw. When we are discussing this climatology, our basic item or our basic tool or our basic scope of study is the atmosphere. During our study of geomorphology, the earth's surface, the rock, okay, different types of rock, different types of landform like the mountain, plateaus, plain, it was the subject of our interest. Now, under climatology, the subject of interest is the atmosphere, that is the surrounding area that is around us. In climatology, it is the climate, the weather phenomena, the wind system, okay, different types of cyclonic circulation, planetary wind system, everything happens, or cloud formation, everything happens in this atmosphere, that is, which surrounds us. So, before we go into the details of this climate or weather phenomena, let us first see the composition of this atmosphere, the subject matter of this climatology. Okay, first we will see the composition. After that, we will see the structure, how the atmosphere is structured. Now, under the composition of the atmosphere, okay, it is composed of three main items. The first one is gases. In the atmosphere or the surrounding area that you see, you have gases. After this, you have water vapor. After this, you have particulate matter. So the entire atmosphere is mainly composed of these particular three items. That is the gases, the water vapor, and the particulate matter. Let us go and see one by one. The gases. Let us first see the composition of these gases. Okay. Now you come here to this particular diagram. The gas consists of nitrogen, which is around 78%. After this, you have this oxygen. In the last class, in the sense in the geomorphology chapter, during the discussion of evolution of the earth, we have seen the evolution of the atmosphere. During our discussion of evolution of the atmosphere, we have seen how the oxygen has come into being in the atmosphere. Clear? Now, after this, the third comes the argon, this table. Then you have this CO2, and you have these inert gases such like neon, helium, methane, and krypton. Now, as far as the exam is concerned, you don't have to remember this particular volume, the numerical figures here. But at least you need to know all of these gases. Krypton is there, methane is there, neon is there. Okay, all of this, it is present. Clear? Why? Because in the exam there may be an MCQ. In MCQ, there will be question like what are the gases which is there in the atmosphere, and they will give you options. In the options, this gas may be given. So even if you don't remember the numerical figure of this, it is important that you at least know the name. Okay. Now, we have what is the function of this particular gases. We all know oxygen is the life-giving agent. Because of the oxygen, the life is possible on the earth. Okay, now, what is the function of this CO2? CO2 is a greenhouse gas. It captures the long-wave re-radiation from the earth's surface and thereby responsible in heating up of the earth. Okay, now it is altogether different thing that in the recent past, because of the anthropogenic activity, CO2 level has increased and global warming is happening. But the naturally occurring percentage of CO2 is also important. And CO2 is important for the plant life also. Okay, CO2 in a very regulated or in a very controlled way, it is helpful. Why? Because CO2 is required by the plant in the process of photosynthesis. Clear? Now, one of the important gases, that is CO2, which is giving us a lot of trouble in the form of global warming, is estimated to have increased more than 10 times from 1890 to 1970. You see here. Clear? Now, let us quickly go ahead. The first one is the gases, which we have already seen. The second is water vapor. Okay, water vapor is another material that you will find in the atmosphere. Now, what is the function of this water vapor? Now, water vapor functions, one of the important function of this water vapor, that is also to heat up the surface. See, whenever you see here, this is Earth's surface, there is a sun insolation. The short-wave sun insolation is re-radiated from the Earth's surface in the form of long-wave radiation. This long-wave radiation is captured by the water vapor, and again it is re-radiated back. This function is performed by this water vapor, and also the function of water vapor is the transfer of heat from one part of the atmosphere to the other part in the form of latent heat. Clear? The third important material which you will find in the atmosphere is the particulate matter. These particulate matter are nothing but the dust. Okay, dust, or it can be any other particulate matter. What is the function of this particulate matter? You see here, the cloud formation. What is cloud? Cloud we will discuss in detail, but in simple way, cloud is nothing but whenever there is an evaporation which is happening in the form of water vapor, this water is converted into water vapor, it goes up. The moment it goes up, it cools down. When it cools down, it will turn into water droplet, finally forming a cloud. Now, in order for the water vapor to condense into a water droplet, it needs a nuclei. Now, this nuclei is provided by the particulate matter which is there in the atmosphere. If there is no nuclei, then the water vapor will not be able to condense. Therefore, the function of this particulate matter is providing of nucleus for the cloud formation. And for precipitation or rainfall, you require a cloud formation. Clear? So, all in all, the composition of the atmosphere is gases. Kindly remember in this manner: gases, water vapor, and also particulate matter. What are the function of these different components? We have just discussed. Okay, gases for giving life, for regulating the temperature of the Earth's surface. Water vapor, again, transfer of heat from one region to the other in the atmosphere. Particulate matter, it gives rise to scattering effect as well as providing of the nucleus to the water vapor for the formation of water droplets or for the formation of cloud. So these are the composition of the water vapor that you will, atmosphere that you will find. Clear? Let us quickly go into the structure of this atmosphere. Okay, atmosphere composition we know: water vapor and gases and particulate matter. This is the composition. Now, the second point is, what is the structure of the atmosphere? You see here, kindly follow the pointer. Okay, this is Earth. Okay, this is Earth. This is Earth's surface. The moment you go away from Earth's surface towards the outer space like this, okay, the entire atmosphere is classified into different layers. The layering of the atmosphere is the first layer from the surface of the Earth to a particular height around 16 km over the equator. It is known as Stratosphere. And if you go again, it is known as Stratosphere. The upper you go, it is known as Mesosphere. The upper you go, it is known as Thermosphere. The upper you go, it is known as Exosphere. Now, one of the main characteristics that you can observe in the structuring of this atmosphere is the atmosphere layering boundary. The boundary of one layer to the other is very well defined in the lower section of the atmosphere. it is quite well defined. Okay, the boundary between one layer to the other layer is quite well defined near the surface of the earth. But the moment you go further away and away into the space, the layer of one atmosphere with respect to the other layer, it becomes very hazy. It is very obscure. You won't have kind of a very distinct or a very clear-cut layer boundary between one layer with respect to the other. The more you go away from the surface of the earth, near the surface of the earth like the troposphere and stratosphere, the boundary will be quite well defined. But the moment you go away, the boundary is not well defined. That's why the final boundary of the atmosphere in the space, how far is the atmosphere, it is not well defined because of the thinness of the air. Okay, so towards the outer space, the boundary of the atmosphere is not well defined. Keep that in mind. Okay, now let us go and see one by one. Troposphere. Now you see here, this is cloud. Now you see, we have seen the composition of atmosphere, water vapor, gases and particulate matter. Now 90% or more than 90% of all this composition of the atmosphere, that is, be it water vapor, and the function we have seen, it functions. What is the function of water vapor? To heat up the atmosphere. Gases, different gases, okay, giving life, the function we have seen. And particulate matter, formation of the cloud. Now 90% or more than 90% of these particles that compose the atmosphere lies within this particular troposphere itself. Clear? Which means what? Maximum number of cloud formation, or you can say almost all the cloud formation, happens within this troposphere only. Okay? You will find some special kind of cloud in stratosphere and in mesosphere, but those are special, very exceptional type of cloud you will find. Otherwise, all the important cloud that you will find within this troposphere only. Okay? Now, let us see. The structure of the atmosphere you see here. About 16 kilometers above the surface, about 90% of the atmosphere has been covered. The meaning of this statement is, from Earth's surface till 16 kilometers above, 90% of the atmosphere is covered. In a sense, the water vapor, the gaseous, the particulate matter is confined within this 16 kilometers. Now, important thing to know about this is, as we have discussed just now, for the cloud formation you need this particulate matter, which means almost all the clouds will be formed in the troposphere. Now, another important point is, because the troposphere is in equator, the height is somewhere around 16 kilometers. In the polar region, it is around 6 to 8 kilometers. Clear? So, all the clouds will be formed within this troposphere only. When there is a cloud, the rainfall will happen. Now, other climatic phenomena also will happen. Why? Because 90% of atmosphere is there within the first layer, that is troposphere. Other climatic and weather phenomena will also happen within this particular region only. Clear? You see here, the first layer is troposphere. It is a region of mixing or convection region. Why? Because you see, since 90% of the water vapor is present in this troposphere, the function of water vapor is heating the earth's surface, at the same time transferring of heat from one particular region to the other by the process of convection. Why? Because on the surface of the earth, when you heat up a water, evaporation takes place. Through the process of evaporation, water is converted into water vapor. Now, in the process of turning water liquid into gas, that is water vapor, a latent heat is given. What is latent heat? Anyone? What is latent heat? Anyone? Latent heat is nothing but the heat which is transferred without changing the temperature when there is a change in the state. So when you heat up a water in the process of evaporation, a liquid is turning into a gas. Water drop is turning into water vapor. Okay, so this latent heat is carried up. When the water is heated, it becomes water vapor, it becomes light, it goes up. When it goes up, it started to cool down gradually. After a point, it will condense. During the condensation, again, this latent heat is given out. Okay, that is how water vapor is able to transfer the heat from one place to the other in a vertical direction. Clear? Now, you see here. Because of this region is also known as region of mixing, that is the troposphere. Wind velocity increases with height in this particular region. And also, the moment you go up, temperature reduces. That is the important characteristics of this troposphere. Clear? Now, you see here, this particular graph or this particular diagram represents the different characteristics of temperature as you move from the Earth's surface above. Okay, in different layers of the atmosphere. We have just seen different layers of the atmosphere like troposphere, stratosphere, mesosphere, thermosphere. Okay, now if you can observe this particular line, this is nothing but the temperature characteristics of different layers of the atmosphere as we move from the ground surface above. You see here, this is a temperature axis. This is 0 degrees centigrade. This side if you go, increases temperature. This side you go, decreases the temperature. Okay, this is a height. This axis is height. Height from the Earth's surface. Now you see here, in the troposphere, you see here, there is a decrease in temperature the moment you move from the ground surface up. From the ground surface, if I go up, temperature reduces gradually like this. Why this reduction in the temperature? This reduction in the temperature is because, yes, we know sun is the ultimate source of energy. Now, say for example, this is sun, this is earth. Okay, this is sun, this is earth. Yes, the sun insolation is coming down like this, but the heating up of the earth atmosphere happens from below, not from above. Keep this in mind. Why it is so? Any one of you tell me. We have just explained that one. The sun insolation or heating up of the earth comes from the sun insolation, which is ultimately the ultimate source of energy. But the heating of the earth atmosphere or the earth's surface happens from below, which means the short wave sun insolation which is coming down after hitting the earth, it gives a long wave re-radiated wave. Now this particular long wave is captured by gases, that is the greenhouse gas, or by water vapor, and re-radiated back downward like this, thereby capturing the heat or heating up of the Earth's atmosphere happens, which means the heating of the Earth happens from below. Okay, therefore if I go up from the Earth's surface above, aren't I going away from the source of the heat? Since the heating up of the Earth atmosphere happens from below, if I go up, I am moving away from the source of the heat. So if I move away from the source of the heat, temperature will reduce. That's why in troposphere, the moment I go up, the temperature reduces like this. You see here. Kindly follow the pointer. See, this is a temperature axis. This x-axis is a temperature axis. This is height. Okay. This is 0 degrees centigrade. This is positive centigrade. This is negative. So the moment I go up in troposphere, temperature reduces like this up to a point. The boundary and the reduction of the temperature stops at some place. It does not decrease further after reaching a point. That particular point is known as tropopause. Okay, that is known as tropopause. You see here. Now you see, from this particular tropopause, if I go up further, temperature is not reducing continuously like this. Temperature is not reducing like this. But rather what will happen is, the more I go up, temperature will increase again like this. Like this, temperature will increase. And this increase in the temperature is known as stratosphere. This layer is known as stratosphere. Okay. In troposphere, temperature reduces, and the place till it reduces, it is known as troposphere. A time will come when I go further up, reduction of the temperature reverses. Rather than reduction, increase of the temperature will happen. And that increase in the temperature layer is known as stratosphere. Now you tell me, just now I mentioned to you that the heating of the atmosphere happens from below. That's why the moment I go away from the Earth's surface above, temperature reduces. But here, temperature is increasing. I am moving away. Then why? Why is the increase in temperature here? Tell me, any one of you. Yes, why there is an increase in the temperature here? Yes, any one of you can tell me? See, under this stratosphere, okay, under this stratosphere, I have a layer known as ozone, or you can say ozonosphere. The ozonosphere, which protects us from the ultraviolet radiation of the sun insolation, is present in this stratosphere. You see here, the layering of or the structuring of the atmosphere, like troposphere, stratosphere, mesosphere, thermosphere, they are based on the temperature characteristics as we go up. Within this particular layering, there will be other important layers also. Okay, so within this stratosphere, there is a ozonosphere, the ozone layer. Okay, ozonosphere, or the layer of ozone. Okay, ozone which protects us from the harmful ultraviolet radiation. Now you see here. Yes, here also in this stratosphere, if ozonosphere is not there or the ozone layer is absent, then the temperature would have been reduced. But the presence of ozonosphere, in a sense, the incoming solar radiation which is coming from the sun is captured by this, and because of formation of this ozonosphere, the sun's incoming solar radiation is observed, thereby increasing the temperature in this particular region. That's why it is known as stratosphere. So in stratosphere, the moment you go up, temperature increases gradually. Now, since the ozonosphere is not available everywhere, the increase in the temperature will also stop somewhere. Therefore, a layer where there is a the temperature stops, increase in the temperature stop, it is known as stratopause. Okay, stratopause. Clear? Is known as stratopause. Now, from this particular stratopause, that is a boundary between mesosphere and stratosphere, the moment I go up further, since in mesosphere you don't have ozonosphere anymore, which means the more I go now, there will be a gradual again reduction of the temperature will take place. Okay, see, let me tell you one thing. Suppose if there was no ozonosphere, even in stratosphere, temperature would have been reduced, because I am moving away from the source of the heat, that is from the ground surface. But because of the presence of ozonosphere, the temperature in the stratosphere increases with height. But after reaching a point, again it will reduce the temperature. Clear? I hope that is clear. Any doubt? Now, after reaching this particular height, around 80 to 90 kilometers above the Earth's surface, again there will be increase in the temperature, that is in the thermosphere. Why there is a increase in the temperature in thermosphere? Okay, now before going into this, let me tell you the ionosphere. Okay, the ionosphere. Ionosphere is responsible for sending back the radio frequency signal, and that is how our communication is possible on the Earth's surface. For telecommunication, for mobile communication, so on and so forth, is happen in this particular thermosphere. And the lower part of thermosphere, I have this ionosphere. Okay, like this. You have this thermosphere. In this thermosphere, in the lower part, you have this ionosphere, which reflects back, okay, which reflects back the radio frequency signal, and which made possible the communication that is happening on the earth. The outer part of this thermosphere, it is known as exosphere. Okay, now let us come to the main point, that is why there is a increase in temperature in this particular thermosphere. Yes, any one of you? See, let me tell you one interesting example. Okay, it will make you understand clearly. You see here, there is a basic difference between heat and temperature. Okay, heat and temperature, they are altogether different concept. Okay, kindly follow with me. Now, increase or high temperature does not mean it has got high heat content. Let me give you one example. You see here, suppose if I have a 1 square cube of a metal, if this temperature is around 50 degrees centigrade. Okay, now another example is if I have a very tiny metal object, okay, very tiny, just like a spark. While doing a welding or grinding some metal, you have these sparks which are coming out. Let that spark be having a temperature of around 100 degrees centigrade, say for example, just for the sake of explaining. Now, which one will have more heat content? This 50 degrees centigrade square block or cubic block of metal will be having a more heat content, even if it is having only 50 degrees centigrade. On the other hand, the spark which that comes out during welding or grinding, even if it is having 100 degrees centigrade, the heat content will be less. Now you see here, we have already explained 90% of the composition of the atmosphere, like the water vapor, like the gases, the particulate matter, is confined within this troposphere itself. Right? Means the moment I go away from the Earth's surface, the composition or the density of the air is becoming very, very, very less. It is most dense near the Earth's surface. It is very dense. Okay, why? Because 90% of all the composition of atmosphere is there within this troposphere only. The moment I go up, it is becoming more thin and thin. Means in stratosphere, it will be very thin. Again, in mesosphere, it will be very thin. Now, in thermosphere, what will happen is the density of the atmosphere will become so thin. One molecule of gas will be here, one molecule of gas will be here, one molecule of gas will be here. Near the Earth's surface in troposphere, it will be, we cannot be able to distinguish. They are too much compressed. But here in the thermosphere, each and every molecule or atom of a gas, like nitrogen, oxygen, helium, it will be scattered like this. Because of that, a single molecule, and this is a temperature characteristics. So a single molecule may have 1000 of temperature. Okay, as far as the temperature is concerned, a single molecule of maybe hydrogen, helium, it will be around thousands and thousands of degrees centigrade. But the heat content will be very low. Therefore, from this particular area, the moment I go up, because of the less dense, it is very, very diffuse here. The atmosphere is very diffuse here. The single molecule temperature is very high. That's why the temperature as such is increasing like this. But the heat content will be very less in this area, in this particular location. That's why it is always said, say for example, astronaut, suppose here, it is not possible in real life, but suppose if he or she, astronaut, is able to take out the hand outside like this, then even if this thousands and thousands of temperature, air molecules or atom temperature, having thousands and thousands of degrees centigrade, if comes and hits the palm or hand, it is not, the astronaut is not going to feel anything. Okay, and that is all because of the density. Density of the air is very, very thin up above. The reason is 90% is confined within this atmosphere, and one of the factors is because of the gravity also. It is confined to the lower section. So this is a broad classification of different layers of the atmosphere. Clear? Now, This layering of the atmosphere is based on the temperature characteristics, as I told you. Okay, temperature characteristics. Now you see here. Another form of structuring of the atmosphere can be done based on the chemical composition. How it can be? You see, we have seen the different components of the atmosphere. We have gases, water vapor, and particulate matter. Under the gases, we have this nitrogen, oxygen. Okay, all of these gases are there. Now, you see here, up to around 80 kilometer, okay, up to around 80 kilometer from the Earth's surface, okay, up to around 80 kilometer from the Earth's surface, which is composed of troposphere, stratosphere, and mesosphere. Okay, see, troposphere in equatorial region, it is somewhere around 16 kilometer from the Earth's surface. Stratosphere is somewhere around 50 kilometer from the Earth's surface. Mesosphere is somewhere around 80 to 90 kilometer above the Earth's surface. Now, up to this layer, the composition of the gas is relatively homogeneous, which means the ratio maintains same. Say for example, if the ratio of combination of oxygen, nitrogen, so on and so forth, other cases, if it is in the ratio of X, say for example 1:2:3, in all of this part, the ratio of composition of the gases, they are same. That's why they are known as homosphere. And this homosphere covers troposphere, stratosphere, mesosphere that we have seen. And this troposphere, stratosphere, mesosphere is nothing but the classification based on the temperature characteristics. But as far as the chemical composition is concerned, this particular layer up to 80 kilometer from the Earth's surface below, this is known as homosphere. Why? Because homogeneity of the gas you will find. Now, above this particular 80 kilometer away in the space, in the upper region of the atmosphere, and as we have already discussed, the outer limit of the atmosphere cannot be well defined. Okay. Now, this upper region above 80 kilometer, it is not homogeneous. The composition of the gas or the constituent of the atmosphere is not homogeneous. On the lower regions, you will find the molecular form of nitrogen and oxygen. Okay, now, if you go up a little bit, then the lighter one, that is the atomic oxygen you will find. Okay, the more you go up, as I told you, the atmosphere is becoming more and more diffused. The density is becoming less and less. Therefore, when you go up, it will be a, molecular oxygen and molecular nitrogen is there here in the lower region in this. But the moment I go up, the molecular oxygen will also be absent. The air is becoming very thin. It will be atomic oxygen. Now the moment I go up, helium, the moment I go up, it will be more concentration of hydrogen. Why? Because it is lighter than helium, which means atmosphere is becoming very thin, very diffused. The density is very, very less. And here the constancy of composition is not there. In the lower part, the atmosphere is mostly consists of nitrogen and oxygen molecules. Above, oxygen atoms. Above, helium. It is more in this region, helium. You will not find molecular oxygen at this level. Okay. And you go up, you have this hydrogen. Clear? So, this particular upper layer is known as heterosphere. So, the entire atmosphere from the Earth's surface above, as far as the major constituent of the gas is concerned, can be broadly divided into two layers, that is homosphere and heterosphere. Clear? I hope that is clear. So that covers our discussion of the nature of the atmosphere. So today we have seen the nature of the atmosphere as well as the composition of the atmosphere. And in this composition of the atmosphere, we have seen the different function that is performed by different components. And also we have seen the structure of the atmosphere. In structure of the atmosphere, we have seen the temperature characteristics as well as the chemical composition and how the atmosphere is divided into different layers. Clear? We'll end the session here today. We will continue with distribution of insolation on the Earth's surface tomorrow. Okay? I hope that is clear. We'll end the session here today. If you have any doubt in any of the point that we have discussed today, you can always revert back to me tomorrow. Okay? We will conduct the session tomorrow at the same time, 11 to 11:40. Okay? I will conduct 15 session. I will try to finish climatology and oceanography in this particular, in this month, that is December. Okay? We'll end the session here today. Yeah? Naveen got. If you have any doubt, you can revert back to me tomorrow at any in the beginning of the session. Okay? Chalo, we'll end the session here today. We will continue tomorrow. Thank you so much for your patience and cooperations. We will meet again tomorrow. Okay? Bye-bye and take care.